So for part one, suppose that we end up with two men matched to the same woman, who we will call W star. For that to happen, in the original proposals, we must have had man 1 being matched to W star, and man 2 was matched to some other woman, say W2, in one of the proposals. And in the other proposal, it must have been man 2 who was matched to the woman W star, and man 1 was matched to some other woman, call her W1. Now for man 1 to end up matched with W star in the combined proposal, he must prefer W star to W1. So in man 1's preferences, W star is greater than W1. But man 2 also ended up matched with W star, so he must prefer her over W2. But what about W star's preferences? Suppose that for W star, man 1 is preferable to man 2. That means that in this case, where she's matched to man 2, W star prefers man 1 to man 2, and man 1 prefers W star to W1, as we've seen from the previous assumption, which means that this would be a row couple. So this particular proposal could not be stable, which is a contradiction. So, in other words, this is impossible. So in that case, W star must prefer man 2 to man 1. But in that case over here, W star prefers man 2 to her current partner, but man 2 also prefers W star to W2, which means that this is not a stable matching. So by contradiction, we can't get that man 1 and man 2 are matched to the same woman in the combined matching.
To prove this formally, suppose that two men M1 and M2 end up matched to W star. This implies that in one of the original pairings, say P1, M1 is matched to W star, while in the other, say P2, M2 is matched to W star. Clearly, M1 and M2 both prefer W star, to their partners in the other matching, where they aren't matched with W star. But that implies that if W star prefers M1 to M2, then the matching where she's paired to M2 is unstable. Since she and M1 form a row couple, similarly, if she prefers M2 to M1, then the period where she is matched with M1 is unstable. Which yields a contradiction.
For part 2, we need to show that the resulting matching is stable. Suppose in the combined matching, M1 is matched to W1 and M2 is matched to W2. But there's a row couple between M1 and W2. So in other words, M1 prefers W2 to M2, to W1, and W2 prefers M1 to a current partner, which is M2. For this situation to arise, we must have that in the original matchings, in at least one of the original proposals, M1 is matched to W1, and in the other one, he could have been matched to some other woman, say W3. And in at least one of the proposals, M2 must be matched to W2 as well. It obviously can't be this one, because then there'd be the same row couple over here, and this proposal wouldn't be stable. So therefore, M2 must be matched to W2 over here. So since W2 prefers M1 to M2, we know that this will be a row couple if M1 prefers W2 to W3. But we know that M1 prefers W1 to W3 because in the combined matching he ended up with W1. So M1 prefers W1 to W3. But we also know that M1 prefers W2 to W1. So obviously M1 prefers W2 to W3, which means that this is a row couple. Therefore, by contradiction, we have that this row couple can't exist in the combined matching, which means that the proposed matching must be stable.
So to write this out formally, suppose there is a row couple M1 and W2 in the final pairing. Which contains pairs M1 W1 and M2 W2, but M1 prefers W2 to W1, and W2 prefers M1 to M2. Then in one of the original match-ins, say P1, M1 is paired to W1, while in P2, M2 is paired to W2, this can't happen in P1 because then P1 would be unstable. But in P2, M1 must prefer W2 to his current partner, because his partner there is less desirable than W1, who he ended up with in the male optimal matching. And W1 in turn is less desirable than W2. But similarly, we know that W2 prefers M1 to her partner in P2, which is M2. So P2 cannot be stable. Which is a contradiction.
So for part 3, suppose that Mrs. Matchmaker is wrong, and in the combined distribution there is at least one woman who is matched to her preferred suitor. So suppose we have in one of the original proposals M1 is matched to W1, and then in the other proposal M1 is matched to W1 prime, and W1 is matched to some other M1 prime. Now we know that in the combined proposal, if M1 is matched to W1, then M1 must prefer W1 to W1 prime. But suppose that W1 also prefers M1. that would imply that in this second proposal, M1 prefers W1, and W1 also prefers M1 to a current partner. That means that this is a row couple, and therefore this is not a stable pairing, which is a contradiction. Therefore, W1 must end up matched with her less preferable partner.
Okay, so to write this out formally, suppose we use Mr. Matchmaker's scheme to combine P1 and P2 into P3. And suppose there is a pair in P3, M1 and W1, where W1 prefers M1 out of her partners in P1 and P2. So assume without loss of generality that the same pair M1 W1 is in P1. Then in P2 W1 prefers M1 to a current partner, but by definition of Mr. Matchmaker's scheme, M1 also prefers W1, which is why he ended up with her in the final pairing. So he prefers W1 to his partner in P2, which implies P2 is not stable, which implies a contradiction. Okay, so for part 4, we can use Mr. Matchmaker's scheme to prove by induction that given any finite set of pairings, we can always find one which is optimal for men and pessimal for women. So let Pn be the proposition we can always construct one which is optimal for men and pessimal for women. P1 is trivially true. Just use the same pairing. Now assume that pk is true. Given k plus 1 pairings, we can use the assumption the inductive hypothesis to construct one which is optimal for men relative to the first k. We can then use Mr. Matchmaker's scheme to combine this with the kth plus 1 pairing in a manner which is optimal for men. Thus, the result must be optimal for men relative to all k plus 1 pairings. Where optimal for men means that in this final combined pairing, the man has the partner that he prefers the most out of all those k plus 1 pairings. And thus we have the proof by induction.